This will be part 2 of lesson 4, and I'm just going to be doing some homework examples, more specifically 9, 11, 13, 15, 16, and 17. So if you had difficulty with those ones, you could watch this podcast. And remember that I wanted you to do these ones as well. I recommend for these ones, make sure you have the teacher solutions open so that as you're going through that, if you get stuck, you can look at the solutions. Okay, so let's do number 9 together. And actually, I need to write that down, what examples I want to do with you guys. So just let me write that in my book. So 9, 11, 13, 15, 16, 17. Okay. Okay, so question number 9. Cos x over 1 minus sine squared x is equal to. So this you're going to have to see is going to be a Pythagorean identity. And the Pythagorean identity, remember, was sine squared x plus cos squared x is equal to 1. So how do they get this 1 minus sine squared x? Like if I look at this and I say, how did they manipulate this to get 1 minus sine squared x? Well, what they did was they subtracted sine squared x from both sides, and they got cos squared x is equal to 1 minus sine squared x. So that is an identity, and 1 minus sine squared x could be taken out, and that could go in. So in the numerator, I have cos of x, and in the denominator, I have cos squared of x. What does this equal? So cos of x over cos squared of x, that's really, a lot of you will see this, but I'll just write it out. Cos of x over cos of x. This would cancel, leaving me 1 over cos of x. And 1 over cos of x, that's a reciprocal identity, and the reciprocal of 1 over cos of x is this secant of x. So 9 would be A. Number 11, cosecant x over cotan of x is equal to. So cosecant, that is a reciprocal trig identity, and cosecant is the same thing as 1 over sine of x. Then it's being divided by cotan. The reciprocal identity for cotan is cos of x over sine of x. Okay, 1 over sine of x times by the reciprocal of this fraction would be sine of x over cos of x. We're multiplying two fractions, so sine of x and sine of x cancel to leave me with 1 over the cos of x. And 1 over the cos of x is a reciprocal trig identity, and that is equal to the secant of x. So 11 is C. 13. Okay, secant x minus cos of x. So secant is the same thing as what is the reciprocal identity for secant. So secant is 1 over cos of x minus cos of x. Fractions, that's really over 1. We need to get common denominators. If I have cos of x on the left, I need cos of x on the right. What I do to the denominator, I do to the numerator. Now my denominator is cos of x, and my numerator is 1 minus cos squared of x. You'll just get into the habit of whenever you have like 1 minus 1 plus and then something squared, you're going to say to yourself, that's probably an identity. And what identity is that? So you look at your formula sheet, and in the Pythagorean identity, sine squared of x plus cos squared of x is equal to 1. So say to yourself, well, what would 1 minus cos squared of x be equal to? So if I subtract cos squared of x from each side, what I would get is sine squared x is equal to 1 minus cos squared of x, and that is an identity, right? So this could come out, 1 minus cos squared of x could come out. I'm going to take that guy out, and I'm going to put in sine squared of x. Okay, now sine squared of x times cos squared of x. So we're not done because normally I'd be like, well, it's in terms of sine and cos, but then if I look over here, I say, well, that's not an answer, right? So what else can I do to this? So I'm just going to rewrite this. Sine squared of x would be sine x times sine x all over cos x. Then what you should see is this guy. What is sine x over cos x? Is that an identity? And it is. Sine over cos is tan x, and then I've got a sine x left over. And that would be my identity there. So this is where like identities sometimes become tricky, because if this was like a quiz question, I would be totally okay for students to stop at this point here. But because it's a multiple choice and nothing matched with the multiple choice, we have to say to ourselves, well, like, how are they going further with this? And the only way I could go further is by expanding, sine squared x is sine x times sine x over cos x is tan x, and then I get an answer. Okay, let's do number 15. Okay, they're giving us restrictions, which is going to be the next lesson. This guy is equal to, okay, so let's do all of our identities in here. So 1 over, what was tan x equal to? Tan x is sine x over cos x times cos x, and that's really over 1, so these are all fractions, times cotan x is cos x over sine x. Now remember when you have fractions, so for example, if I had 2 over 3, 2/3 times 3/4, what we do with fractions is we multiply numerator times numerator, which would be 6, and denominator times denominator, which would be 12. The other thing we could do is we could reduce if I needed to. So 6 over 12 is 1/2, but what I could have done is I could have said, oh, 3 over 3 will cancel, and I'm going to be left with 2 over 4, which is 1/2. So here, yes, I could multiply numerators and denominators, or I could say, oh, cos over cos would cancel, and sine over sine would cancel. So it looks super messy, but get rid of that guy. Get rid of one of your coses. And then we've cleaned this up greatly. We've got 1 in my numerator, and in my denominator, I have cos of x. I could put cos of x over 1, but I don't need to. It's 1 over the cos of x. So this is where like identities, when you get used to it, it actually becomes fun, because something that looks super scary is going to clean up really nicely. So 15C. Okay, let's see if we can have the same fun with 16. Tan over cos. So what was the identity for tan? Tan is sine of x over cos of x times cos of x over 1, right? Over. And then you guys look, cos of x over cos of x. Yay. Okay, that's fine. Okay, what do we have in our denominator? 3 times secant. So secant was a reciprocal identity for 1 over cos theta, times cotan. What was the identity for cotan? And cotan was cos theta over sine theta. Theta over sine theta. Okay, we're multiplying fractions, so cos over cos would cancel. And I've got 3 in my numerator because 3 times 1 is 3, and I've got sine in my denominator. So up here, I had sine over 1, which is just sine of x, divided by 3 over the sine of x. This is the same thing. We're going to multiply by the reciprocal. So sine of x times sine of x over 3. This is equal to sine of x and sine of x is sine squared of x all over 3. And I look and I'm like, ooh, I think I have the answer. What you need to realize is that the number in front of the sine is 1. So this is really 1/3 times sine squared of x. And identity is done. Last question, number 17. When verifying this identity here, for x is equal to pi over 7. So they want us to check left-hand side and right-hand side. It says the value of each side of the identity to the nearest tenth. So if I was to plug in pi over 7, and this is going to be a calculator question, so I'm going to go back to change my mode to radian mode. So enter, get out of here. And what they want, cotan squared theta plus 1 is equal to cosecant squared theta of x. And okay, so if I was to plug it on the side here, what they want us to check is what is the cosecant of pi over 7 squared. Cosecant is the reciprocal of sine. So 1 over the sine of pi over 7 squared. So if I was to type that on my calculator, let's see what we would get. So 1 divided by, we're doing the reciprocal of sine. So sine of pi over 7, close that bracket and square it. On the right-hand side, I'm getting 5.3. But I've got to check that I get the same thing on the left-hand side. So cotan squared theta, that identity is 1 over tan of pi over 7 squared. And then I've got to add 1 over here. So let's check if this left-hand side is equal to 5.3. So on my calculator, 1 divided by tan of pi over 7 squared gives me this. And then when I add 1 to that, because remember it was that plus 1, I get 5.3. So 5.3 on the right, 5.3 on the left. Left-hand side equals right-hand side. And my answer would be 5.3.